Hello everyone, and today I'm giving a presentation on Singularity. So Singularity is a tool that's available on our newer systems and on some legacy systems. And it can be very useful, but if I'll say this much before I start, if we already have the software installed on our existing systems, please use that. Don't try to redo it in Singularity. Just like last presentation was about cloud, it looks great and wonderful. But again, if there's other ways that are already configured, please use those ways first, unless you have some interesting cases, in which case you might want to ask us for help by submitting a ticket. Start off with, what is Singularity? Singularity is free open source software, and it's created by Berkeley Lab. And it's a secure way to use Linux containers on multi-user clusters on systems in general. But when you have lots of users, security becomes an issue. It was created as a way for users to have full control of their software environment. Pretty much the only thing you don't control are some of the mounts and the kernel that is running. Singularity depends on the kernel running on the operating system. But everything else is contained inside your Singularity image. And Singularity was designed as a way to package scientific software and to deploy that different clusters, to do compute, high-performance computing, and things like that. Those clusters will need to be of the same architecture. So Singularity uses something called containers. You may have heard of virtual machines if you're familiar with the software VirtualBox, or if you're familiar with VMware, which is a commercial product. Those are virtual machine environments. They essentially simulate the chip. So because they do that, you install everything. You install the kernel, you install everything into those virtual machines. Containers don't emulate the chip. Instead, they rely on the kernel of the host operating system, and because they're at a little bit of a higher level, they have significantly less overhead. But a restriction is they can only run the same operating system inside the container. So since our systems run Linux, you can only run Linux inside of Singularity. That's not a huge drawback for our use case. So a container itself uses something called control groups in Linux, kernel namespaces, and an overlay file system. So control groups limit, control, and isolate resource usage. So, RAM, disk, I/O, CPU, things like this. The namespace both virtualize and isolate those resources to a set of processes. And then there's an overlay file system that is used at various times. Now, the reason this is important is none of this involves, once it's configured, none of this involves you having special permissions to run stuff. So you can be given access to stuff, and your access is appropriately limited by the use of namespaces and cgroups. So this is part of the magic of what makes Singularity really nice and more secure from the point of view, hey, there's thousands of people that can log into our systems, and you want to know that there's no security issues yourself, but more importantly, too, the sysadmins and the network admins want to know their things are secure. So this is really nice that Singularity exists because it has been specifically set up this way. So from the get-go, ensuring security and proper containment of access is established. Okay, so just to mention one other thing, there's another tool that is similar, and if you've heard of it, then Singularity is very similar, but it has fewer features because of its design goals at this current time. And that other tool that is very popular is Docker. Unfortunately, Docker requires various elevated permissions, so that can pose potential security risks. So, and they do impose on how things are set up by the administrators. So that said, all is not lost. If there's a Docker image that you must absolutely use, there is a way of setting up a Singularity image directly from that Docker image. So installing Singularity, well, it's pretty easy on our existing clusters. Graham and Cedar, it's there. On some legacy clusters, it's also there. That said, if you want Singularity installed on a machine, or the request that you need to do so in the ticket, the root user, the super user of the cluster or system has to set up Singularity. If you were to compile Singularity in your own account and try to run it, it's not going to work very well, if at all. So it has to be configured by root. So the existing systems, Graham and Cedar, no problem, it's there. And on legacy clusters. One quick word about legacy clusters. The Singularity on legacy clusters will have some limitations. So that's because they're running older kernels and older configurations. But on the new clusters, we're okay. Graham and Cedar, you don't have to worry about them. Specifically, like on CentOS 6, which is the old clusters, that's running the 2632 kernels. There's limitations there. No overlay file system stuff really, and some of the other features are quite limited. However, it can work, and there are ways of making things work, so that are fairly straightforward. So you can do that. Now, CentOS 7, it's a 310 kernel. Frankly, if you're using anything with a newer kernel than that, there should be zero problems, so that's a good thing. So upgrading on one hand sometimes is a pain. On the other hand, it opens the door to running nicer software like Singularity. So when you want to load Singularity on Graham and Cedar, you would load them with putting module load Singularity and put the version number. If you don't put the version number right now, you get Singularity 2.3, and I strongly recommend, unless you have a very good reason to use version 2.3, to use version 2.4. Your files are backwards compatible and all that stuff, so if you had it from version 2.3, it should still work. But they changed the command line interface to be much easier to use with version 2.4, and it is way easier to build new images and do things like that with version 2.4. On Orca, the module for 2.4 isn't enabled just yet, but you can use the 2.4 version just by setting your path variable to put Singularity in it. And if you need to use 2.3, you can load that version there. I'll only be talking about version 2.4 in this presentation. Now, when you use a tool that lets you use containers, or for that matter, even when you do a virtual machine, you're effectively doing the same thing, but that's more complicated. But when you're using containers, you have to create an image. Now, this image is a file. In Singularity, it can also be a directory if you need to update or do read-write things with the image. But I'm going to talk about it as if it were a file, because when you officially make your image and you're done and you're going to use it, in Singularity, the default image format is one file, and it's a compressed SquashFS file. So if the image itself, uncompressed, I don't know, takes 4 gigabytes, compressed, it might take 1 or 2 gigabytes depending on the files in there. So it saves some disk space. The other thing that's nicer about everything being in one file is that it's nice with the file systems that are Lustre. Lustre does not like lots of tiny little files, and unfortunately, these files in an operating system are a whole bunch of tiny little files, and this is an inefficient use of your Lustre disk space. So, when you finalize your image, you produce it as a file, which is the default way of doing it, so that's very easy. You produce it as a file and then you upload it, and then you can put it in your Lustre space or wherever you want. The image itself will be, it can be other minimal sets, but it will be an installation of some Linux distribution. I have tested myself things as old as Fedora 10 all the way up to Fedora 27, for example. I've tested other Linuxes, the latest cut, bleeding edge stuff, and things seem to work. So that's wonderful. So as long as it's Linux, you're good. So you can make images by downloading a container from Singularity Hub. Singularity Hub is a site they've set up where people can share their Singularity recipe, which is the bottom bullet, and those recipes are instructions on how to make an image from scratch or from existing images. It is very similar to Docker in that sense. So you can download a container from Singularity Hub with a URL from Singularity Hub. You can download a container from Docker Hub. If you already have a container, awesome. If you have a tarball, uncompressed or gzipped, that'll work. If you have a directory that has a file system set up in it, that'll work as well, or a Singularity recipe file. So quite flexible. This is not existing, any of it, in version 2.3. In version 2.3, rolling out images is hard. It's pretty much you have a tarball or a directory and you build it from there. There are some other cases, but it's not straightforward to do them in all ways. So version 2.4 is well worth using. So suppose you go to Singularity Hub, which is singularity-hub.org, and you find an image you like. You trust the stuff with that image, so there's nothing untoward in there and all that. And let's say you were looking for Ubuntu. Well, you don't have to set it up yourself. The URL from Singularity Hub is the shub://SingularityHub/Ubuntu. So all you have to do is once you load the Singularity module, you can go Singularity pull, put the URL, and it will download it. Very straightforward and elegant. Nicely, you can do the same thing with Docker. So if you go to Docker's Hub and you find a Docker path for it, you can put docker:/ in front of that path and download that into Singularity. One word of warning here: if you are using Docker and you want to modify that image, for example, you want to upgrade it. Often upgrading the image, you'll need to be on a read-write file system. I'll talk a little bit about that after. And you'll need to be root for some operating systems to properly upgrade. So that means you will have to do it on your own machine, because everything you do in Singularity on our clusters is completely within your user permissions. There are no elevated permissions at all. So if you need to manipulate images, it is worth installing on your own computer Linux. If you don't have Linux anywhere, install it in a virtual machine, then install Singularity in there, and then you can work on your images. Now, nicely, if you already have Linux on your own computer, right, and it is set up, you got all your software working, many do when they're doing their research, and they say, oh, I need a compute cluster and this and that, but you got all complicated setups and this, and to recreate all of it, you can't use it quite on ours because you have to recreate all of it, and it's just way too much work. There is a nice, easy way to make a Singularity image. You can make a tarball of your entire system. You can exclude some of the things you don't need, like deb, proc, and this, and other directories that you have on your system that you don't need. You put that into a tarball. Okay? Then if you transfer that tarball to a computer with Singularity, or if it's already on that computer, fine. You'll be able to do the next step. Now I want to mention right here that if you don't need to if you don't need to preserve file permissions in your image, you don't need to use root to manipulate your image. But many will with many Linux distributions, so if you do, then you'll need to use sudo. But if you don't need to preserve file permissions, you can run all of these commands. They will work on our clusters. You just omit sudo. Every time you see sudo in these slides, you omit it, and it will work. That said, if you need to preserve the file permissions, it's because these are file systems, and file system I/O goes through the kernel. So things that have higher elevated permission settings need to have root. So this is why that's the case. Okay. There are ways sometimes of using images. You totally don't care about the permissions. You're never going to upgrade. Then you can totally do without using sudo, and you can do stuff on Graham and Cedar and other systems without any special access. Okay, so you take your tarball. This is an optional step, but often when you make a tarball of something, you want to do a few tweaks. Like you might want to edit the password file so there's no local accounts in there, and maybe you have /home, you missed it, and /home's in there, and you want to remove it or set things up differently. Things like that. Clean up the var directories. You forgot to delete all the logs, etc. Well, all you have to do is untar that. And on the system where there's Singularity, and then you can just go Singularity shell. -W is important. That allows you to write to it, and the directory you untarred it into. So then once you're in there, I recommend you run bash, so you get the bash shell you're used to. Singularity will give you a minimal bash shell. So you run bash, and then you do whatever you're going to do. And then you type exit to exit out of the first bash, and then you exit one more time to exit out of the bash Singularity gave you. So Singularity shell is the interactive command to manipulate your image. So finally, you can create the image. So you have that working directory. That's a read-write working directory. But you want a file that's nice and compressed, and that'll be a read-only file. And you can do that with Singularity build. So you just go Singularity build, and the way build works is you put the name of where things are being written. So the image you're building first is put first. So I put that image, my image.simg first. The convention is to put Singularity image files ending with simg. And the file where everything is work first, so that'll do it. If you didn't make that working directory and you had the original tarball, then the line after that is how you do it. Singularity build, put your image, and then you put the tarball. Okay, and then when you're done, upload that image to your cluster that you're using that has Singularity installed, and you are in business. Another way of doing it, sort of the same task, if you had Singularity installed on the system, and you wanted to not make a tarball and just have Singularity just make from your system straight out the image, this is how you would do it. You'd make a recipe file, it's just a text file. First line is bootstrap. Second line, you put all the directories you want to exclude. Okay, so those are probably some of the ones you'd want to exclude. If there's others, add them. And then all you have to do, you would want to use root for this to keep the root perms, but if you don't care, you don't have to put sudo. But you put Singularity build again, and you put the name of the image you want. I call this one self.simg. And then you put the name of this Singularity recipe file. That's it. Wait for it, and when it's done, you will have an image. There's more that you can do than that in a recipe file, but that is the minimum. You can also build a recipe that's a little more elaborate. If you use Bootstrap's local image, you can specify a Singularity image, an existing Singularity image, an existing Singularity image file or directory. You can also specify a tarball. Now, what this will do is it will take that existing from whatever it is, from being the Singularity image file or directory or the tarball, and it will apply the rules in the recipe file. So I put a little help thing here that allows people to run Singularity help on a file and find out what it is. And but the %post section are a series of things it does to update the thing. So I said, well, what if I wanted to use an Ubuntu 16 image that was pristine, but I need to install some additional software on it, and I just want to script it. Now, most people wouldn't have a use for this, but some would, and certainly staff members of Compute Canada supporting users would have a use for this. And what you can do is you can put all the commands you want to do that would cause it to be upgraded. So as you can see here, apt-get update, apt-get upgrade, which is how you update an Ubuntu system. And then we're installing Build Essential, which we'll put on all the compilers and things like that. Install Git, install a bunch of Python stuff, install Vim, and then clean up those extra files because it just wastes space, the downloaded files. So it's clean, boom. And what Singularity will do is when you run the command at the bottom of the screen, it will uncompress the Singularity image file that's in the from line, put it in a temporary directory, and then it will run all those commands in the image as root. Well, because I put sudo, it will run them as root in the image, and then it will install them, do everything necessary, and when it's done, it will take that whole directory and make it into a new image. And that file that it makes it into is immediately, as I said before, after the build command. So new-ubuntu-image.sing will be the final result. If any errors occur along the way, that new file is not made, it's aborted. If you have to manually debug these, then you want to run Singularity shell, uncompress it yourself, and then do Singularity shell and figure out what's up. So using Singularity, 2.4 is a lot easier to build the images and to use them in many ways. There are 3 ways you can use Singularity. One is to run a single command. So you have your favorite program you run, you compute something, great. That's the only thing you do. You pass it the input file, done. Okay, that's one way. You might want to have an interactive session. So you might actually want to do a bunch of things manually. I don't know, maybe you're doing a bunch of commands and then you're playing around with some paraview stuff and you remotely connected into interactive session through Slurm on Graham or Cedar, that kind of thing. So there's that use case. And then finally, an important use case, Singularity allows you to run instances, daemons, that have background processing. And unlike Singularity 2.3, 2.4 won't cause these weird hung processes. For example, if you were to be in an interactive session and you backgrounded a program, if you were running an instance and you backgrounded it, everything in the instance is going to be okay. You can access that program's process ID and deal with things. If you don't do that, if you run it the single command way, you can leave yourself in a position where the backgrounded process is still running and you have no way to get at it other than to kill the whole Singularity process. So they took care of these nicely in version 2.4, and if you want to do these background things, the way to do them I'll be showing you in these slides is to run container instances. They're actually pretty cool. Now, first way I mentioned, you just want to run one command. I don't know, you want to run GCC and find out the version in the container. So the command is GCC-V. GCC is installed in your container. All you have to do is put, no sudo now. You just put Singularity exec, the name of the image file, space, and then the command you want to run, whatever that command is in the container. So when you run it, you'll see that the GCC version is not the same as what you're used to on Graham or Cedar or whatever system. It's whatever you installed in that container. And whatever programs you have in there, that's how you can run them. So the trick is you're running all of these as your own user account. So there's no security issues, happiness is. If you want to do interactive use, then it's easy. You go Singularity shell and the image name. Now a little caveat here. That image name is read-only. Whether you use shell or exec, or it doesn't matter. It's always read-only. The image file is a squash.fs, which is a read-only file system. If you have a directory, you can tell it, oh, I want read-write settings on this, and you have to pass in a -w and things like this. But if you're doing that, you're probably updating or building your container. So that some of that is beyond this presentation today, but there is a way of doing it. And it's very important if you are doing that and you want to write to it to put a dash, because if you don't, it will use overlay FS to make the writes look like they're writing, and when you exit the shell, you'll find out nothing got written. I made that mistake once. Anyways, when you're in the shell, you do your stuff, and then you type exit. So typically, your image has all the software you want to have installed, so you do your stuff with it. You can manipulate your files in your home directory and all these places, and then, okay, it works. You know the commands you need to run. You can type exit, and maybe you paste those Singularity blah, blah, blah commands into your Slurm script to submit a job. Now, if you want to run backgrounded and or daemon processes and play around with them and have that sort of thing, then you want to use Singularity instances. What you do first is you start an instance. So you say Singularity instance start, the name of your image, and give it a name. Okay, whatever the name is, you actually, I call it session 5 here, so you can have session 5. Very nice. Singularity will very quickly start a new instance. You can even see all the instances you're running, Singularity instance.list, and you'll see the name of the Singularity instance. You'll see its PID, process ID, and the container image path. You don't have to guess where it's running from. You'll know where it's running. This is all nicely compatible with everything we do on the system. You don't have to worry about stuff. So programs then can be run with exec or shell as before, except you specify the name of the instance and you prefix that with instance : //. So if the name of your instance is 1, that first line there, Singularity instance start image.simg 1, so my instance is called 1, okay, then you want to run something in it, okay, the next line does that, Singularity exec image.simg, look, instance : //1, so that I'm running the 1 instance. So you can have more than 1 instance running and they can be, doing different things. That's fine. And the command I'm running is ps-eaf, which will show me all the processes running in that instance. Okay. The next line shows shell being used, and then that line, notice I use no huff, so I run find on the system in the background. And I write everything to a dump.txt file, and then I exit out. Okay, normally you would never do this because exiting out you would lose control of that process. But with a Singularity instance, you can get back in there. You can go Singularity shell blah 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 instance : //1 and get back in and kill that process if you want, or get the process list, or use exec to do that. So this is a wonderful tool, and if this was part of your job you were running on our systems and it exceeded the RAM or the runtime, from our point of view, the program comes in and kills your job because you exceeded your maximum amount, then this kills everything, including those backgrounded processes. So it's very nice, it's very compatible with everything we're doing. Good for everyone. So you want to shut it down? Great. You just go Singularity instance stop, and you specify the image and the name of that session, and that will kill everything that is associated with that. So very handy. So the next thing one ponders is, oh, I got my disk space. I got disk space in home. I got disk space in project. I got disk space in work. I got disk space in Scratch. I got disk space in local Scratch. I got disk space all over the place. What am I going to do? Well, Singularity supports something called bind mounting. So by default, we bind mount the system mandatory things really like /dev and /proc and /sys. Otherwise, things won't work right. So we bind mount those items, and some other little details are set. But by default, the thing that is nice, that is bind mounted, is your home directory. So it's not just your home directory, /home is bind mounted. So if you're in a research team, you can go /home/ your fellow research team member account name, and access files that you're sharing in your accounts that way. So awesome. So you'll say, what about all those other directories? Okay. Well, you have to, the other directories, you have to manually specify what those are. Fortunately, it's not hard, with the -B option through the shell and exec command. Okay, -B means bind. That's for bind mounting. There's a long form of it, but -B is way shorter to write. So on Compute Canada, you probably want to mount these directories: project, scratch, and local scratch. You might have other ones, whatever. Okay, some people might actually have a need to actually mount CVMFS. So fine, you would mount that. It doesn't have to be /project at the top directory. It could be /project/this/this. It could be a specific directory, and you can say, I don't care about anything else. That'll work as well. So how do you do that? Very straightforward. Any Singularity shell and exec command, immediately after shell or exec, put -B and put a directory. And if you have 15 of them, then put -B, the directory, and do that 14 more times for all the directories, and you're good. And then you can put the name of the image. And then what's after that is the same thing as you've seen before. Awesome. So this will allow you to access all your disk space. Singularity is compatible with the auto mounter stuff and everything we have. So doing these top directories is sufficient. If you do this, you will be able to access your files for everyone in your research team the way you normally do before you might have used Singularity. So that's wonderful. On the legacy systems, mind you, like Orca runs CentOS 6. Before this will be successful, you have to make a work and scratch directory in your image. Any -B setting you use, you have to make a directory for that in your image, because overlay.fs is non-functional in those versions. So, but it would be a slightly different list of directories if you're using Singularity elsewhere. In Compute Canada outside of Sharcnet, the directory names might be slightly different, but you would run it the same way over the directories you want to use. Okay. Now another nice trick that you can do with bind mount is, well, take the example I have here. I have make directory local scratch /temp $user. So my username is Preny, P-R-E-N-E-Y. So that's my username. $user is set to that when I log into the system. So that'll make local scratch /temp /Preny. Okay, so my own directory in local scratch. Now what I can do is I can run my Singularity image, saying Singularity shell. I'm going to use it interactively, or you could use exec. But I put -B, and I put that path, local scratch temp, Preny. Colon, that colon's important, /TMP. Now what does that do? Well, it means inside the image, any program that's running from inside the image, okay, if it accesses the TMP directory, which is temp, okay, it will think of that directory, it will think of it as temp, but in reality, that temp space is not /temp when you log into Graham. That is /local scratch /temp $user, which is Preny if it were me. So that's awesome. You don't have to, so if you want to do this, if you want to change where things are, for example, you need to use a lot of space in temp, and you don't want temp in RAM, for example, then you would want to use this kind of bind mounting to actually change the location of where the files get read and written from. This bind mounting feature does have an additional feature. If you put one more colon, you can say R or RW to stipulate whether it is a read or read-write mount. By default, it goes with whatever it is. Most of the time you want read-write, so there's no need to add it. But if you needed to make a read-write mount read-only, you could add a :R after that. So that's extremely handy. There are users where that is of use. It would also be of use in some cases where you're using proprietary software that wants to assume things are at certain locations and they're not there. So Singularity hopefully can help with those situations. So there are some issues with Singularity. One issue that's a non-issue, nicely with Singularity, if you're using GPUs, Singularity, they explicitly put into Singularity support for NVIDIA. All you have to do is pass the --NV option to exec or shell, and I believe the run command. But if you pass the --NV option, it will make the Singularity GPU available directly to the image. Of course, you have to have the right versions of the NVIDIA software installed in the image, but that's okay. The hardware devices and that are available to your image. So yay! So if you have TensorFlow in your image, you definitely want to use the --NV, for example. TensorFlow with the GPU support, you want to put --NV so that will work properly. You also need to, I reiterate, to install the correct versions of CUDA for the GPUs we have on our clusters. And the correct version has to be inside the image. The downside for a lot of programs or many users, it's life, Singularity is not a panacea, but it's pretty darn good. But if you're using MPI, and a lot of programs do make use of MPI, especially if it's not threaded MPI, because threaded MPI does not take advantage of the network fabric because it's running all on one computer, and it can just do things with the various CPUs. So if you're using threaded MPI, you probably won't have any problems as long as you're on a single node and you don't try to do anything across nodes. Once you try to do things across nodes, the MPI in your image must be configured with all the fabric inside the image properly. Otherwise, it's not going to work. You'll get various errors and things like that. You can try to bind mount the system's MPI and the network fabric, but that's problematic. And the reason is that our Compute Canada systems are running CentOS 7, but all the software is installed with a hybridized version of Next and EasyBuild, and those are in the /cvmfs directory. So they're all buried under there, and those use a different glibc. And so you have a glibc for the operating system. You have various possible glibc with settings with the Next EasyBuild stuff that's in CVMFS, and you also have the glibc that's in your container. And it is very likely when you get 3 versions of glibc going, you're going to have compatibility issues and they're not going to work. So the solution for making MPI work is, if it's not version 2.1, and you're going to try to make it work, you need to make sure pretty much that the version of MPI in your container is configured exactly in the same way with the exact same version of MPI that's outside the container. Okay, so my advice would be to use version 2.1. Version 2.1 is a little more flexible. They've intentionally designed, they work with OpenMPI to design things to work, which is wonderful. The only thing you have to do with version 2.1x versions of MPI is to make sure you have all the required networking fabrics installed inside your container. If you do, then stuff will work. And this is for going across nodes. If you're threaded all in one node, things will work. If you have OpenMP, which is all on one node, things are going to work. That's normal. It's when you're going across the nodes and you're leveraging the network fabric, you need to have that configured properly. So there's a little caveat. A lot of programs use MPI. That said, a lot of programs use MPI in ways that won't pose any issues. So that's great. And for those programs that need to go across nodes because you're using more than 32 CPUs, then that's an issue, and this will have to be addressed, in which case you may well want to submit a ticket, and staff members can help you deal with this issue in terms of getting your Singularity image properly configured so MPI can work. Want to say thank you and have some questions. There is a little bit of time, so I will show you a little bit of Singularity in action, and so show you a little bit of that, and I'll mention, reiterate one very good use case for, two very good use cases for Singularity are if you're a researcher and you need customized environment. I remember a ticket some time ago where the researcher needed customized versions of build tools like Clang and GCC and things installed, and they're so customized and tweaked and altered, and in some other tools, same thing, that they're only useful for that researcher. So that's a good use of Singularity. You can put everything you need to into Singularity, put it up on the system, and it's going to work. Nicely, it's going to work on Graham, and you can upload the same file to Cedar, and it's going to work the same way on Cedar, etc. So that's wonderful. The other case that can be useful is there are a number of commercial software programs, and the vendor is completely uncooperative. So what you can do is if the version requires Fedora 18, and it's many versions newer now, but you need Fedora 18, and there's too many things, and you've already tried the patch alpha command, you can't get that to work, and you've tried RPath things and other things, and you can't get things to work right, then it's worth a shot. Give Singularity a try, because you can put Fedora 18 into Singularity and install your software in there, and then the only issues you got to figure out, if it uses MPI, you got to figure out the MPI issue. But maybe that leads to a nice solution. And if so, great. And guess what? Once that works, since Graham and Cedar are set up the same way, you'd be able to copy that image, from Graham to Cedar or Cedar to Graham and use it. Presumably, you can probably copy that image to the new Niagara system when it's up. So that would be very handy because that would increase the number of systems your software would work, and it was a big pain to get it running in the first place. So that probably is a good use of Singularity if Singularity is applicable for your situation. So I'm going to switch my windows here to show you Singularity. Here we go. So if I log into Graham, okay, logged into Graham, and I have already loaded a Singularity image up. Okay. Quick aside, I have created a whole bunch of Singularity images. From OpenVZ and other images, I've created a bunch of Singularity images for a whole bunch of Linux distributions. So if you need a base image to start off with, please submit a ticket. I may already have that image created. It's currently residing in my own disk space. So later we'll have to get an official spot where these things are residing in our Qt Canada setup. But that image can be made available to you. In the ticket, I can say, copy this into your directory or download it, and you're off to the races. So you don't have to worry about that starting image if you don't want to do a Docker or a Singularity hub thing. Okay, so I have this. Now the first thing I want to do is I want to do module load Singularity. Okay, and if you've never used it before, please use version 2.4. Let's do this. Awesome. So now that we're loaded, let's do the simplest thing we can do. One of the simplest things is we can go Singularity exec, exactly what I showed before, and I need to put the image, so that's Ubuntu, and then let's just run gcc-b to see what version is installed in there. Now this is Ubuntu, and GCC is not installed in that image. I forgot. Okay, well then that's the pristine image where I didn't install GCC. Uploaded the wrong image. That's okay. We'll run the ls command, but we'll do it a little differently. We'll put ls and we'll output the root directory, ls/. Okay, so if we look at the files we have here, the directories, that is the root directory of the image. That's not the root directory of Graham. The root directory of Graham looks like this. You can see there's more directories, right? There's archive, cvmfs, we've got local scratch, we've got local, there's an initRD thing here. Okay, so there's all these other directories. So if you don't bind mount something, you don't see what is on the system. So now, just to really show this, I'm going to change exec into shell. Then I'm going to get rid of the ls bit. I'm going to hit enter. So now it says Singularity invoking an interactive shell within the container. Okay. Now, this is a bare bones shell prompt. Just type bash and you'll get your usual prompt that you're used to. Okay. So now, right now I'm in my home directory. And remember, I said the home directory is auto-mounted. So this is my home directory. So if I were to create a file here, let me create a file. I'll just quickly create it. TTT, there I go, TTT. That file will exist when I exit out of the shell. Okay, but if I go to the root directory, this is not the root directory of Graham. This is the root directory of my image. Okay, if I go to user local, this is user local in my image. If I go to bin, there's nothing in there, things like this. So you'll see that the directory setup is different. So then, if I exit out, you can see my TTT file right here. But let's, for fun, bind mount a directory. Okay, we'll bind mount project. Okay, we do this. That wasn't in there before. Now we do bind mount on project. I'll just run bash. If I ls/, okay, magically project appears here. Okay, so Singularity uses overlay.fs to create the appearance of project. So this allows me, if I wanted to, go into my Crenny project directory. There I go. And I have a whole bunch of Singularity images in here. Okay, so that's my project directory. So that's how I do it. Now, if I didn't put that project in there, then I go to use Singularity, and I try to go into project. No such file or directory because project doesn't exist inside my container. Okay, so there's programs in here. You can run your PS. Some of it will, show you various things because you are on a running system. Okay, but if you had compilers installed in this image, my apologies, I forgot to put the one with compilers. You would see that they're the compilers you have installed. They're not the ones on the system.